Next topic is integrated law for a zero order reaction. Already we see first order. Next is zero order. In case of zero order reaction, suppose A gives product. In this case, rate expression is rate equal to K into concentration of A per 0. That means rate is independent of concentration of the reactant. Rate is independent of concentration of the reactant. It is called as a zero order reaction. Rate is independent. Zero. It is an independent of the concentration of the reactant. In this case, rate equal to K into 0. So anything power 0 value 1. So rate equal to K. So rate expression is minus of dA by dt equal to K. This dt play on right hand side. So minus of dA equal to K dt. Same. Integrating the above equation. Integrating the above equation between the limits. So already I mentioned for initial A naught time is 0. For final it is A at time t. Substitute this equation. So integration of concentration of A naught, concentration of A minus dA, d of A, constant is K is constant, taken out from the integral 0 to t, integral of dt. So on integration of dA, answer is A. So minus concentration of A, limit is A naught, A is on K, on integration of dt it is t, 0 to t. Substitute the limit, so you get minus concentration of A, minus concentration of A naught equal to K into t minus 0. So minus of A plus concentration of A naught into K into t. This one you rewrite as concentration of A naught minus concentration of A equal to Kt. So we have to calculate rate constant K. Then the above equation K is equal to concentration of A naught minus concentration of A by T. So this is a rate constant for a zero order reaction. So next we calculate half-life. So half-life for zero order reaction. Half-life for zero order reaction. Definition already we studied in first order. So no need. So study the definition. Here same time rate constant for zero order reaction K is equal to A naught minus A by T. In case of half-life, T will take it as T off, and the concentration of A will take it as A naught by 2. That means concentration of the reactant to 1/2 of its initial value of the reactant. So initial value is A naught, so A naught by 2. Substitute this A and T in the above equation. So K is equal to concentration of A naught minus concentration of A naught by 2 divided by T of. So this one on cross multiply 2 into concentration of A naught minus A naught divided by this 2 will go to denominator 2 into T of. This 2 A naught minus A naught, so 2 minus 1, concentration of A naught divided by 2 into T of. We have to calculate half-life, then above expression T of equal to concentration of A naught divided by 2K. This T of will go left hand side, K will come comes to the denominator. This is the T of a zero order reaction. This is all about the integrated law of zero order reaction and half-life of zero order reaction. So one more topic in this here itself I explain. It is given in a textbook. It is an pseudo first order reaction. Pseudo first order reaction. It is an important topic. It is given in the textbook. So I will explain here. So here I will explain pseudo first order reaction. Pseudo first order means, what is pseudo order? Pseudo order means, pseudo order, general definition for pseudo order means altered or reduced order of the reaction. Altered or reduced order of the reaction is called pseudo order of the reaction. Pseudo order. You are going to study pseudo first order. Pseudo first order means, in a second order reaction is converted into first order reaction. How we will convert second order into first order? By increasing the concentration of one of the reactant. Excess concentration of one of the reactant. Suppose if two reactant is there, means you increase the concentration of one reactant, then second order will be reduced to first order. How it is reduced? Consider the example, hydrolysis of ester. Hydrolysis of ester. In 10th standard we studied. So ester CS3 COH5 on hydrolysis in the presence of acid to form CS3 COO CS3CO C2H5, which we consider only the reactant side, no need to consider product side. So for this expression, rate is directly rate equal to K into this one I write it as ester into concentration of H2O. So always it is in second order reaction because number of reactant this is 1 and 1. So overall it is in second order. It is in second order. We have to convert second order to first order. So already we know concentration of water. We increase the concentration of water. There is no change in the reaction. When you increase more amount of water, there is no change in the reaction. So we can take it as this K and H2O. Take it as K dash. Equation it is equal to K dash into ester. You see it is in second order, it is reduced to first order. It is called a pseudo first order. The pseudo order means order reduced order. Pseudo first order means in a reaction by increasing the concentration of one of the reactant, it is converted into first order. It is called as in zero order. Remember, the first order means in a second order reaction by increasing the concentration of one of the reactant by converting into first order. The reduced order is called pseudo first order. So this is all about pseudo first order reaction. They will ask in exam. So important topic, 3 mark or 2 mark question they will ask. So that's all about pseudo first order.